So in this video, let's see an example for Turing machine. The Turing machine, Turing machine is of two types. Okay, one is Turing machine as acceptor. The other one is Turing machine as computing device. So we all know acceptor is accepting some language of some form. For example, a power n, b power n. Check whether the Turing machine accepts a power n, b power n. Okay, or some language of this form. Okay, these are Turing machines as acceptor. What is computing device? Like performing addition of two numbers, subtraction, multiplication, or even complement of two numbers. So these are the Turing machines as computing device. So now let us see an example for Turing machine as acceptor. Design a TM for 0 power n and 1 power n. Okay, where n is greater than or equal to 1. So let's see. First, as we all know, Turing machine has a input tape of this form. So first, say our n is equal to 3. 0, 0, 0. Okay, number of zeros equal to number of ones. So 3 zeros and 3 ones. Then after this, it's all blank spaces. Okay. So your input head is here. We will first look at the logic, then we'll move on how to design a Turing machine for that particular logic. So how will you count number of zeros and number of ones? So according to our question, the number of zeros should match number of ones, right? So same way, you first find a zero, then move on in the tape and find a 1. Okay. So if you cannot find a 1, then the Turing machine will reject the string. Okay. So first you find a 0, replace it with x. Why are we replacing it with x? Okay. Now we are moving forward to find a 1. Okay. Now we have to come back. You have matched the 1 with x. Now you have to go find the whether there is another 0 and another 1. So now you are coming back. You're if you have not replaced this 0 with x, you are having a 0 again. So there will be a mismatch, right? You will again match this 0 only with another one. Keep on matching this 0 with another one. So that would not be good, right? So that is why we are replacing this 0 with x so that next time you visit, the Turing machine won't consider this 0. So how will you find the next 0? Right, okay. So what for the logic for that is you keep moving the tape towards the left until you find the x and move one step right. So if I move one step right, then obviously the next 0 would be the leftmost 0. Okay, so this is the logic. You match each 0 with each 1. Okay, replace all of them with x and y. So you have replaced all of them. Your input tape head would be here. Next symbol should be what? 1, right? Next you are going to find a 1 for that particular 0, but you find a y. So that means your string is over. Okay, now you have to accept this string. Now you cannot accept a string in between, right? So you keep moving until you find the blank space. Until you find the blank space, then move one step left because your string is here only, no? So your string is still here only. Blank space is not included in a string. So it is just an indication that we have reached the end of the string. So move one step left and accept the whole string. So this is the logic for 0 power n and 1 power n. Let's see how we can design a Turing machine. First, you have a state Q naught. What is the first step? So you have 0, 0, 0, 1, 1 and 1. Rest all blank spaces. Okay, first step is to replace this 0 by x. So 0 replaced by x, comma, keep moving right. We can write this template as 0 replaced by x or 0 comma x comma r or 0 vertical line x comma r. These three are acceptable templates. Okay, you move to the next state. in between, what are you trying to do as a next step? You're going to find 1. Okay, so in between you have zeros. So what should you do? You have to ignore those zeros. You put them in the self loop. You replace 0 with 0 only. Don't do anything and keep moving right until you find a 1. When you find a 1, you replace that 1 with y. Okay, now move left to find the next 0. Okay, now you have replaced this one with y. Your input head is here. Now we have to move left. Okay, in between you have any number of zeros again. So what would you do with those zeros? Put them on self loop. Replace 0 with 0 and keep moving left. Okay, okay. Till when you have to keep moving left? Till you find a x. Okay, till you find x. Keep moving left. In between you will have, sorry. So you will have zeros and that zeros we have put on self loop. Okay, so if you find x, what you should do, you don't do anything. Now move one step right. Okay, one step right, that is why we have put it in a transition. If there are like so many steps in between, we would have put it in the self loop. Okay, so it's just one step right, move one step right, and what are you going to do? You are going to find the next zero and replace it with x. Okay, then you are going to move the input head and you are going to find the next one. So this same loop again, right? So instead of doing that again, we will connect this transition to the Q naught phase. Okay, Q naught phase x. Don't do anything, keep moving right. So you change it and keep moving right. In between you have 0, we have put that in the self loop. This time we have y also, right? So we have to put that transition also here. Y, don't do anything, keep moving right until you find a 1. Replace that 1 with y. Okay, then move left. Then move left until you find a until you find another 0. Okay, in between again you have y. Okay, so what would you do with those y's? You put them on self loop. Y tends to, y replace it with y, keep moving left until you find the x. Okay, after you find x, move one step right and replace that with x. Okay, now your input head is here. Now your input head is here. You are moving one step right. You are moving one step right. You have to find a 1 now, but there are no ones, there's only y. So what would you do that time? Okay, that means your string is over. Okay, you have to move to the blank space as we discussed already. If your string is in string, you have matched all the x's with all the y's, then you move till the blank space, move one step left and accept the string. Okay, so that transition is not here. We have given only 0 when it is 0. So if it is not 0, if you have y, what should you do? If you have y, you move on to the next state. Okay, don't do anything. Keep the y as it is. Keep moving. Right. In between, you'll have any number of y's. You'll have any number of y's. Okay. Don't do anything. Keep moving right until you find what? A blank space. If you find a blank space, don't do anything to the blank space. Just move one step left and accept the string. Because your string is before only till the 1, right? Y, last y. Your blank space is not included in the string. That's why we move one step left and accept the whole string. So this is the Turing machine for a power n, b power n or 0 power n, 1 power n. Hope you understood. Thank you.